Yes, it is more practice with fractions. Good morning. As a reminder, we're going to take TSI on May 8th and 9th. The first question, this is a word problem. Most of us struggle with word problems and we often even skip them. Are we ready? Are we ready? Question number 1 and 2 are from the same problem. Question 1 says the formula, we've got a formula, gives the temperature in degrees Fahrenheit for a given temperature in degrees Celsius. What's the temperature in degrees Fahrenheit when the temperature is 50 degrees Celsius? I've seen this problem numerous times on TSI. So it gives us this formula, and it's also giving us 50 degrees Celsius. So we're going to write the formula and we're going to plug in for Celsius. These little calculators kind of suck when we want to do fractions. So we have to figure out how to do fractions with these calculators. One thing that you can do is simplify. That always helps. So here, you're multiplying 9 times 50, and then you're dividing by 5. But 50 and 5 will reduce first. So can't you divide 50 divided by 5? What's 50 divided by 5? 10. So you can change that and this becomes 10. That's a little easier for most of us. So what is 9 times 10? 90. And then we have 90 plus 32. $122. The next section is a bunch of just adding or subtracting fractions. And so mainly you need to make sure that you have like denominators. Hello. He is. I will gladly send him over. I think. Okay. Amir, you are in ISS. For question number 3, we already have like denominators, so we can add them. When you have like denominators, the denominator stays the same, and really all you're adding is the top. So we got 5 plus 3 is 8. Does that reduce? What does 8 over 4 reduce to? Just 2, right? Or 2 over 1, yep. The next question, do I have like denominators? No. So I have a 4 and I have a 2. I can turn the 2 into 4. What would I have to multiply by? 2. Well, I have to multiply the top and the bottom. So on the top, I get 2 times 3, which is 6, and I can't forget I have a negative sign. And then 2 times 2 is 4. Not that. When you already have like denominators, your denominator stays the same, and now all you're adding or subtracting is just the top. So I have -6 minus 1, so I'm getting more negative. I get -7. And that doesn't reduce. The next question, do I have like denominators? So what should I do? What should I multiply by? 2. I'm going to multiply the second one by 2. So in the numerator, I get 1 times 2, which is 2, and then over 6. When the denominators are the same, they stay the same when you add or subtract. And all I'm adding is the top. So 1 plus 2 is 3. Does that reduce? To what? To what? 3 does go into 6 2 times, but the 6 is bigger on the bottom, so it has to be 1/2. The 2 has to be on the bottom. There is one more problem I want to go over with you, and then I'm going to give you time to work on the front. So up at the top, it's over here. This one, I don't know why it restarted numbering, or just this one is 1. It's weird. It says if 6 over a divided by, 6 times a divided by 2 is equal to 12, then a equals, so we're just solving for a. That's really it. So to solve for a, we need to bring over the 2 and multiply by 2. Twelve times 2 is 24. And then I just have one last step. What should I do? Divide by 6. What is 24 divided by 6? Very good. So I'm going to give you guys some time to work on that front side. All right, let's continue. So, would you rather always be overdressed or underdressed for every occasion? Underdressed. Okay, I'm gonna be wedding. I tend to agree. I usually dress comfortable. I agree. Would you rather have telekinesis or telepathy? Okay, so we gotta talk about the difference. So
Wouldn't you go crazy? It's not gonna lie.
probably.
This is in your way.
Yeah, I tend to agree. Would you rather never be able to go out at night or never be able to go out during the day? I need the sun, so I would have to be able to go out during the day.
At night.
Yeah, that's what I think.
But did that make no difference?
Maybe.
Zoom class. They have a lot of fun stuff happening there.
I have the worst childhood ever. Teacher.
You could just, I guess, invite people over.
I don't like to go like. Remember
Would you rather get a paper cut every time you turn a page or bite your tongue every time you eat? I don't want either one of those. I bite my lip more than I bite my tongue. I don't really want either one of those things. I don't want either one of those things. Would you rather be forced to dance or sing every time you hear a song?
Like out loud and then like looking at the bill.
I don't know. Yeah, I'd probably rather. I don't sing well, but I'd probably rather sing.
Wait, is it like dance, like is it good dance?
I suppose it's whatever you're capable of as far as dancing or singing. I'm not a good singer, but I still probably would rather sing every time I hear a song than dance. Every song. Maybe you're like humming along like when kids sing a song. On to the back of our worksheet. So question number 13, these on the back, is there an equal sign? No, so you cannot cross multiply. You can only cross multiply when you have an equal sign. That's the only time. That's the only time it works. So for these, you are just multiplying. And when we multiply straight across. Sometimes you can help yourself if you reduce first. So if you look at 10 over 9, does that reduce? No. What about 16 and 13? No. But you can also look diagonally to see if things reduce. So 10 and 13, can that reduce? No. 16 and 9. No. All right. Then we can just multiply straight across. So we've got 10 times 16. And there's an n, so the n is still there. And then we have 9 times 13. You might have to type that one into the calculator. You might not be able to do that in your head. So 160 and 117, those are not really numbers that reduce, but you have n over n squared. So remember that that's the same thing as like n over 2 n's. So anytime you have a pair of them, it reduces to just 1. So any pair you can kind of mark out. So one of those goes away. That's it. Question 14. Let's double check to see if anything reduces first. So 16 and 17, that doesn't reduce. What about 16 and 8? Yeah, that could reduce. So 16 over 8 would be 1/2, but I have to write it with the 2 on the top because the 16 is bigger. Hey, look, I also have an X and an X, so those can go away. And if you simplify before you multiply, then it makes it just a little easier. 2 times 6 is 12, and then it's 17 times 1. And that's it. And that's how you do the whole top section. The bottom section is all solving. So the bottom section, question 19, my goal is to get the fraction by itself. So I can subtract 2. And so we remember from last class that if you have a fraction equals something, you can always make it 2 fractions. And then we can, because there is an equal sign, we can cross multiply. So we get 4 times 4, which is 16, is equal to 1 times x, which is just x. Yep, that's fine. That's all you'd have to do. Question 20. We can move over the 10, so we can add 10. Five and 10 is 15. We have one last step. We need to divide by 9. Uh, 15 over 9, does that reduce at all? Yes, it can reduce because both of them can divide by what? 3. So you can divide by 3 and divide by 3. 15 divided by 3 is 5. 9 divided by 3 is 3. So at the bottom, some of the answers are fractions, not a whole lot, a couple of them. And some of them just have fractions in the answers. Because I reduced 15 over 9. I'm reducing. So that is the rest of the worksheet. "20 minutes, I feel like should give you enough time to finish the worksheet and then we will grade it.
Oh, take that.